So I even wrote that down. That's Einstein's theory of general relativity. The whole theory of gravity, the best theory of gravity we have, in one line. Actually, this thing here just tells you how the mass of a planet or a star is distributed, and this thing here tells you how space and time curve. And that's it. That's all there is to it. And then the picture is that as things move through this curved space, they bend because they're going through a curved space, and that's what we feel as the force of gravity. About 2 weeks ago, a fascinating little experiment was completed, a thing called Gravity Probe B. It was a spacecraft that orbited around the Earth and just measured the curvature of space and time. And it did it in a very simple way using little spinning tops called gyroscopes. Just carried them around the Earth. Einstein's prediction was that as they went around the Earth, the gyroscopes would move a bit. And they would move a bit because space and time are curved. So they wouldn't quite come back to pointing in the same direction every time they went around. That movement, that little shift, was the amount that if you look at the planet Pluto, well, it's not even a planet now, it's so small, it's been demoted. If you look at Pluto from the surface of the Earth, and you look at the angular distance between the top and the bottom, so measure the angle looking at the north pole of Pluto down to the south pole of Pluto, then that's the amount of shift in these little gyroscopes. Einstein predicted it in 1915. It was measured 2 weeks ago, and the prediction was in exact accord with the measurement, as far as we could tell. So Einstein's theory has been tested utterly beautifully and precisely just in the last few weeks, and it was in complete accord with his predictions from 1915. A beautiful bit of physics. So